Okay, welcome to Pure 1 International Mathematics, Edexcel, Jan 2022.
Okay, question 1, we need to integrate. So step 1, we're going to rewrite everything in index form. So a over 5x cubed minus 2 over 3x to the negative 4 minus 1 with respect to x. Okay, so we're going to increase the power by 1, divide by the new power. We're going to get x to the 4. A over 5 divided by 4 is 2 over 5. Okay, increase the power by 1. X to the negative 3. Divide by the new power. Positive 2. Increase the power by 1. Over 9. Increase the power by 1 is x. And then what is that magical thing we need? Plus c. There we have it. Nice and easy, first 4 marks on a paper, isn't it? Okay, question 2. So let's have a look at question 2. So we have a quadratic, express it in this form. So first of all, we need to complete the square, right? So for part A, we're going to divide everything through by negative 2 first, so that our x squared has a coefficient of 1. So we're going to have x squared plus 2x minus 11 over 2. So now what we can do is go on to complete the square as normal. So we're going to have x plus 1 squared minus 1 squared minus 11 over 2. It's going to give me minus 2 lots of x plus 1 squared. Minus 1 minus 11 over 2 is minus 13 over 2. Then we're going to multiply everything through by negative 2. So we're going to have positive 13 minus 2 lots of x plus 1 all squared. And there we have it. We've completed the square. Okay. It then says, part B, sketch the graph of the curve with the equation showing clearly the coordinates of the points. Okay, this is lovely. Right, we've got to sketch this graph. First of all, what do I know? Negative quadratic, so it's going to look like this. Okay, it's sad. Right? It's not happy. It's negative, feeling down. Okay. What do we know about the y-intercept? What's my y-intercept? 11. Okay. What do we know about our minimum point? The turning point is minus 1, 13. Okay. And then what I can do is I can quickly put this into my calculator. Does it solve? Yeah? What do we get? Put this into my calculator, what do I get? Actually, no, we don't need to. It just says where it crosses the y-axis. Okay? So, sketch. Right, so when I sketch this, it's really important that I'm using a ruler. Okay, I know I'm not, but you should be. You should also be using what? A pencil. I know it doesn't want us to write the coordinates down, but when you put this into your calculator, what do you get for 2 solutions? Because we know it's going to cross at 11. So,
plus 26 over 2, which is 1.54.
1.54 and?
Minus 3.5.
And minus something, okay? So we know we're going to have 1 on each side. We know that negative 1, 13. So we think negative 1, 13 is going to be our maximum point. So it needs to be more over like this, okay? Here we have it. So we know that we have negative 1, 13. Make sure we write down this as y. We know this is 0, 11, and this is x. And there we have a really beautiful sketch that's going to give you 2 marks. So it then says write down the equation of the line of symmetry. Now the line of symmetry is in fact the line what x equals minus 1. Okay? So there's the line of symmetry. So that's an easy 5, 6 marks. Yeah, the line of symmetry is a point on the turning point because it's symmetrical about that line. Question 3, part I. Now, if we really read the top part of this in bold writing. You must show all stages of your working. Okay? So solutions relying on calculated technology are not accepted. So it wants us to expand this and express it in this form. So I'm going to do that over here. Oh, I forgot I learned a new trick. Okay, perfect. So I'm going to move this over here so that we've got some space. Right then, so first of all, I'm going to expand this one. So x plus root 2 squared is x plus root 2 times x plus root 2. We're going to have x squared plus 2 plus 2 root 2x, and that's because I've got root 2x plus root 2x, okay? We should be all happy doing this in our heads, right? Now the next one, 3x minus 5 root 8 squared, 3x minus 5 root 8 squared. So we're going to have 9x squared. Now we're quite lucky here, this is a plus, okay, so I'm not going to worry about any negatives. Minus 5 root 8 times minus 5 root 8 is positive 40, is that right? No, it's not. It's not. 5 times 5 is 25 times 8. 200, perfect, thank you. Okay, then we're going to have minus 15 root 8x. Minus 15 root 8x is minus 30 root 8x. Okay? So, what we're going to have, let's collect like terms. So we're going to have x squared plus 9x squared. That's easy, isn't it? What do we get? 10x squared. We're then going to have 2 root 2x minus 30 root 8. Now, this is where you really need to make sure you don't just go straight in for the answer, right? We have a root 2 and a root 8. So, 30 root 8 is the same as 30 root 4 root 2, right? Yeah. Which is 30 times 2 root 2, which is 60 root 2. You need to show that that is 60 root 2. So 2 root 2 minus 60 root 2 is minus 58 root 2x. If you do not show that that 30 root 8 is 60 root 2, you're going to lose 1 mark here. Then, lastly, we have 2 plus 200, 202. Okay? We now have it in that form. So we've got 10x squared minus 58 root 2x, well, 58x root 2, if we're being a bit pedantic, plus 202. Perfect. Brilliant. 3 marks. Okay, 4 marks. Solve this equation. Nice and easy. Expand, simplify, you could even divide, however you wanted to do it. But basically we need y's on one side, everything else on the other. I'm going to expand first. So 4 root 3y minus 3 times 3 is 9 equals 5y plus root 3. I'm going to move the 5y to the left-hand side, the 9 to the other side. So 4 root 3 minus 5y equals 9 plus root 3. Now we're going to factor out a y. Okay? Now you can see I am showing every step. We have to show every step. Divide both sides. 9 plus root 3 over 4 root 3 minus 5. Now, how do you think I go from here? What do I do? Rationalize the denominator. So 4 root 3 plus 5 over 4 root 3 plus 5. So, here we have it. On my denominator, I'm going to have 16 times 3. What's 16 times 3? 48. Minus 25. What is 48 minus 25? 23. Okay? Now, 9 times 4 root 3. 36 root 3. Root 3 times 5. 5 root 3. Root 3 times 4 root 3. It's 4 times 3. It's 12. 9 times 5. 45. So I'm going to have 37 root 3. No, I'm lying. 41 root 3 plus 57. Is that right? So then I'm going to have 41 root 3 over 23, 57 over 23 added together. Okay, so it doesn't look as pretty. However, it is correct. So there's 7 marks. Make sure you show every step of your working. Okay, question 4. Oh. Right, so you must show all stages of your working. Again, no calculators solutions allowed. So, it shows a line with the equation x plus y equals 6 and a curve with this equation. The line intersects the curve C at the points P and Q. Use algebra to find the points P and Q. So we should all be fairly confident right now that this is simultaneous equations, yeah? Simultaneous equations with quadratic. So first of all, let's rearrange x plus y equals 6. We're going to get y equals 6 minus x, okay? So, instead of writing y, I'm going to put 6 minus x equals 6x minus 2x squared plus 1. Okay, so now, if I take away x from both sides, I'm going to move everything to the left-hand side, actually. So, 2x squared minus 7x plus 5 equals 0. Okay? So, I wonder, can we factorise this? Maybe.
Sorry, I'll have to use a calculator because
2x, yeah, you can use a calculator, but it says solutions relying on calculators won't be fully accepted. So even if when you use your calculator, so like you get your mode, equation, 3, and you type in 2 minus 7, 5, you're going to get 5 over 2 and 1. So minus 5 minus 1, right? You can put it back into the factorised form. But it shouldn't be difficult to factorise this. 2 numbers that multiply to give you 5, you've only got 1 and 5 because it's a prime number, right? So x equals 1, x equals 5 over 2. Now, the key part of this question, and people don't realise this, is the substituting back in. So that means y equals 6 minus 5 over 2, and y equals 6 minus 1. So y equals 5, and normal. 6 minus 5 over 2 is 7 over 2, and y equals 7 over 2. Now, the most important thing about this question, guys, it asks for coordinates. These are coordinates, guys. 5 over 2, 7 over 2, 1, 5. If you do not have them written like this, you've lost a mark. Straight up. Did you not do it? You've lost a mark. No, you didn't lose any. Well, that's fantastic news. Mohammed? Okay, good. Coordinates, guys. Coordinates always come in the form x, y. So please make sure we've got that. Right, so now we found the coordinates of P and Q. It then says the region shown in the shaded figure is bounded by CL and the x-axis. Fantastic. Use inequalities to define the region. Okay, we've already been given everything we need to know. So first of all, is it below the line? So x plus y is less than 6. Okay? Is it less than or equal to? Less than or equal to. Okay? I think in the mark scheme, though, as long as you stick with the same thing. Right. How would I know this? Okay, how do I know it's less than or equal to? It's because we want below the line, right? Next. Y, now do we want above the curve or below the curve? Above. And above it, on the outside. So that means y is greater than or equal to 6x minus 2x squared plus 1. Because this is above the curve. Yeah, like in here is under the curve, it's less than, right? And then what do we know? X is also, not X, Y is also greater than or equal to 0, or else they would have shaded it down here. It's 3 much, you need 3 inequalities. Okay, now don't forget there's one other thing, right? I'm saying all of this, however, this could also apply to this part of the line, right? Do you see what I mean? So we need to now stipulate something else, because we don't want it to apply that line. We want to make sure that X this is only for X is, now if we said 0, we'd still include this bit. Do you understand? You know, we just worked out where Q was. What was the coordinate of Q? The coordinate of Q was 5/2. So we could say that X is greater than or equal to 5/2. Now, we don't have to say that X is less than or anything, because even if we said X is less than 10 and 10 was over here, for example, if X is less than 10, it wouldn't matter, because this would still be, it wouldn't, this is like below the line where Y is negative. Okay, so that's going to give you full marks on the whole question. So, question 5. Figure 2 shows a plan view of a semicircular garden. The semicircle has centre O, diameter AOE, and radius 3. Okay, they haven't put that on there, so I'm just going to put 3 here, right? Because we know that's the radius. The straight line BD is parallel to AE. Okay, so these two lines are parallel. It's handy to know. Angle BOA is 0.7. Step 1, what am I going to do? Calculator, radians, okay? It's just hit me then that we are now in radians. I'm going to do that straight away. If I don't do that, I'm going to forget. So, radians, here we go. Then, show me that 4 significant figures, angle BOD is 1.742 radians. So we've got to show this. Okay, so.
Miss, the other side's also 0.7, right?
So why is this side 0.7?
It's because both of them are the same angle, like the same size.
Who said who? So these are parallel, right? We know that this is a radius, we know that this is a radius, okay? So, first of all, this is 0.7, and because this triangle is isosceles, this is also 0.7, right? Because we have the two radiuses. Radius, so isosceles. So this is 0.7, this is 0.7. Angles in a triangle add up to what? 180 in terms of pi? Pi.
So we do pi minus 1.5.
Pi minus 0.7 plus 0.7. Okay, so we're going to do that, and shift pi minus 1.4 equals
1.7.
Yeah, so angle BOD equals 1.742. Perfect. So we've done it. Right. Then it says the flower bed R shown shaded in figure 2 is bounded by BD and the arc BCD. Find the area of the flower bed given your answer in square meters. Okay, so we want the flower bed. So basically, step 1. I'm going to find the area of
The triangle.
the sector minus the area of the triangle. Okay, and you know what I'm like? I love drawing. I love to see what's happening. It's how my brain works. So we know that this is 1.742. We also know that this is 1.742, and we know that these sides are 3, right? Yeah. So how do we find the area of a sector?
Half r squared theta. Half r squared theta.
A half r squared theta minus a half
AB sine c.
AB sine C. Perfect. Okay? So, let's put this all in the calculator. 0.5 times 3 squared times 1.742 minus a half times 3 squared times sine of 1.742. Okay, this gives me 3.404788, etc. What does it want it to? One decimal place.
So 3.4.
3.4 meters. Okay, perfect. Now, it says find the perimeter of the flower bed. Okay, arc length plus that top of the triangle, right? So what is arc length? Theta times radius. So what do we already know this is 1.742 times my radius, which is 3. Okay? Now, how do I find the length of the other length of a triangle? So we have to use cosine rule, remember, to find this length here. So a squared. I think, do you get this in the formula? Plus a. Okay, so we need to know this. So we know that a squared equals b squared plus c squared minus 2bc cos a. And then we square root it, right? So 3 squared plus 3 squared minus 2 times 3 times 3 cos, times cos of 1.742. I get like 21 point something. Square root the answer. I get x equals 4.59, right? Etc. So I need to do 1.742 times 3 plus the answer. So this gives me a grand total of 9.815. One decimal place, 9.8 meters. I just realised this was meters squared earlier because we were talking about things. So 9.8 meters. So actually, that was a really nice question, wasn't it? Yeah? Beautiful. Okay, question 6. The curve C has this equation given that f dash of x. Now, what does this already mean? This is the gradient function. So this means this is a formula for the gradient. Okay? The point P lies on this. Find the value of the gradient at P. Okay. If we're going to find the value of the gradient, we're literally just going to substitute in 4 into this equation because we've been given the gradient function. So what am I going to have? 49 over 4 times 2, 8. Perfect. So there's the gradient of P. Hence, find the equation of the tangent. Equation of the tangent. Do I have to change the gradient? No? No.
Y equals mx plus c.
So 49 over 8. What's our coordinate? 420. So if we're using y equals mx plus c, I'm going to have 20 equals 4 lots of 49 over 8 plus c. So you can do this any which way you want. 20 minus 4 times 49
It's going to be
is 196 over 8 equals c. What is 20 times 8? 160?
160, I think.
Equals c. So I'm going to have minus 36 over 8 equals c. Is that right? Okay, so minus 36 over 8. We know that we can, that's minus 18 over 4, which is minus 9 over 2. Okay? So you can simplify this. Brilliant. So now we have y equals 49 over 8x minus 9 over 2. It wants it in the form ax plus by equals c. So I'm going to multiply everything through by the largest denominator, which is 8. So I'm going to have 8y equals 49x minus 9 over 2 times 8 is minus 36. I'm going to move everything to the left-hand side. 8y minus 49x plus 36 equals 0. Now, if you have your pluses and minus the other way round, that's also okay. Perfect, so we've done that part. And they're all in integers. Now, the 7-mark question is it wants us to find f of x, okay? So I now need to integrate this. So I need to integrate x plus 3 squared over x root x with respect to x. Okay, step 1. What's step 1? Index form, okay? So let's expand, simplify, sort our lives out. So x plus 3 squared, remember it looks like this, so we're going to have x squared plus 6x plus 9, okay? If you don't know how I did that, I know I've done that quite fast, but we should be able to expand quadratics like this now. Now, we know that x to the 1 times x to the half, because that's our denominator, is x to the power of 3 over 2 with respect to x. So we have a fraction. We can now sort this out. So let's split this fraction up. This is the same as saying x over 2 over x to the power of 3 over 2. 6x over x to the power of 3 over 2 plus 9 over x to the power of 3 over 2. Now, we're still not in index form yet because we haven't simplified all this, right? That's what we're going to do now. So now, x squared divided by x to the power of 3 over 2. Take away the powers and have x to the power of a half plus 6 x to the power of negative a half plus 9 x to the power of negative 3 over 2 with respect to x. So I've had to do all of this before I even start integrating. Are we now ready to integrate? Absolutely. How do we integrate? Increase the power by 1. Divide by the new power. Which question is this? I have no idea. I think it's 6. Yeah, I'm on the same question as you. You told me we were on the same question. Right, increase the power by 1. A half. Divide by the new power. What's 6 divided by a half? 12. Increase the power by 1. Negative a half. Divide by the new power. Minus 18. And then what do we have to? 100% right. Plus c, absolutely. So y equals this plus c. Now, we're not quite finished yet because we need to find c. Now, lucky for us, they gave us a coordinate in the question. What coordinate did they give us?
X, which is 4.
They gave us 420. So that means when x equals 4, y equals 20. So I'm going to write 20 equals 2 over 3 lots of 4 to the 3 over 2 plus 12 lots of 4 to the power of a half minus 18 lots of 4 to the negative a half plus c. I'm now going to be able to find out what c is. Right, let me put this all in my calculator. Okay. I think I get 61 over 3 plus c. 20 minus that, I get c equals negative a third. Did anyone else get that? Yes. Fantastic. Okay. This is great. My calculator's working. So now we need to write the whole thing. So that means f of x equals, and I'm going to cheat a bit here. Here we go. I'm going to write that down. Yay. Oh, wrong one. There we go. And then, instead of writing plus c, I'm going to write minus a third. Okay? Okay, question 7. Figure 3 shows a sketch of part of the curve with the equation y equals f of x. Now, I know we should probably read the whole question first, but let's just sort some stuff out. X equals minus 4 is the solution. So I know this is minus 4, 0, right? Because it's when this equals 0. X equals 2. And 2x minus 9, what do I know that is? 9 over 2, 0, which is like 4.5, right? But fractions are our friends, so, you know, love them. Now, how do I find the y-intercept? What do I do? Yeah, I'm going to multiply the numbers because I know that when I expand this, so 4 times negative 2 is negative 8, times negative 9 becomes positive 72. So I know that this is 0, 72. Brilliant. So, I may or may not need this for the question. I'm betting we're going to need it, right? So it says, given the curve with the equation y equals f of x minus p passes through the points with the coordinates 0, 50. So instead of passing at 0, 72, where's it going now? 0, 50. So it's shifted down by what?
By 22.
By 22, absolutely. So the constant p is y equals f of x minus 22. Okay, because we've moved down. How do you get from, if it was at 72, but it now crosses at 50, well, it's shifted, hasn't it? Do you remember? Inside or outside the bracket? Who does it affect? Yeah? Outside the bracket affects y. What do? Up, down. We do what it says, right? So, given that the curve with the equation y equals f of x plus q, is this inside or outside the bracket? Who does it affect? X. So we're now saying, and we're going to do the negative, right? So we're now saying it shifts so that it crosses at 0. So that means this has moved to 0. So what's happened? What is it? This point now crosses through the origin. Plus 2. So this is going to be y equals f of x plus 2. Okay, because we do the opposite, right? It means we're minus 2. Then, it says find f dash of x. So we need to differentiate this. To differentiate it, what do I first need to do? I need to expand it. Okay, I need to expand this. So let's go, let's do some expanding. I'm going to start with these two first. So, blah, blah, blah. X squared plus 2x minus 8. Now I'm going to multiply that by 2x minus 9. We should be, you know, really fast at expanding now, shouldn't we? Yeah? So I'm going to multiply everything by 2x. So 2x cubed plus 4x squared minus 16x. Now I'm going to multiply everything by negative 9. Minus 9x squared minus 18x plus 72. Guys, if you're not getting 72 here, you've gone wrong somewhere. We already discussed it was 72, didn't we? Yeah? So now I'm going to have 2x cubed minus 5x squared minus 34x plus 72. This is what f of x equals. So if we differentiate this.
Minus 34.
Wait there, sorry. So bring the power down. What, 6? 6x squared, decrease the power by 1. Bring the power down. 10x, decrease the power by 1. Minus 34. So this is what f dash of x equals. We differentiated, right?
Yeah.
I don't know what the rest of the question is telling me to do. Done. Okay, it says, hence find the range of the values of x for which the gradient of the curve of the equation is less than 18. So we want to know, when is 6x squared minus 10x minus 34 less than minus 18? Okay? So this is when 6x squared minus 10x minus 16 is less than 0. Yeah? Okay, so I can literally put this into my calculator, right? It didn't really say show all your working, did it, on this one? Okay, I'm going to figure out that I'm going to get 3x minus 8 and... Okay, now this is where some of you are going to struggle, right? I get 3x minus 8 and then it tells me the next solution is 1, right? But let me tell you now, if I was to expand this, am I going to get 6x squared? No. So make sure you put a 2 here and then this becomes a 2 and it makes more sense, right?
And the question says y equals f
Yeah. But it says, I know it says y equals f of x, but it says hence find the range of values for which the gradient, okay, you need to read, yeah? Of which the gradient of the curve is less than minus 18. So that's why we do that, right? So now, remember, if you are using this, remember to watch out for that. You still should be double checking that this expands to get what you need. So we're going to x equals 8 over 3, and then x equals negative 1. Because 2x, if 2x plus 2 equals 0, x is still going to equal negative 1. And you know that 3x times 2x is 6x squared. Now, if this is less than 0, if we were to just draw a quadratic, where is it less than 0? In this part. So this means we want one inequality. Okay? Does it say anything else about k? What does it say about k? Find the range of values. Why have I written k? What could we put? X. There we go. Okay, find the range of values for with the equation is less than minus 18. Brilliant. It didn't say less than or equal to. So that is going to be our final answer. Question 8. The line L1 has this equation. Find the gradient of the line. So what am I going to do? I'm going to rearrange it into the form y equals mx plus c. So I'm going to move 5y onto the other side. Equals 2x plus 7. Divide everything by 5. 2 over 5x plus 7 over 5. What is my gradient?
2 over 5.
2 over 5. Perfect. So it's given that point A has coordinates 6 minus 2. The line L2 passes through A and is perpendicular to L1. Find the equation of the L2. Okay, if it's perpendicular, what do we know? Yeah, the gradient is the negative reciprocal. So the gradient of the perpendicular line is negative 5 over 2. We have a point, 6 minus 2. Are we now able to find the equation of a straight line?
Yes.
Okay, so y equals mx plus c. So minus 2 equals minus 15 plus c. So c equals 13. So that means y equals minus 5 over 2x plus 13. Is that right? Minus
Yes.
5 over 2x plus 13. Brilliant. Says the lines L1 and L2 intersect at the point M. Use algebra and show all your working to find M. So what does that mean? We got another simultaneous equation. Love it. So, I'm just going to do 2 over 5x plus 7 over 5, because that's what y equals minus 5 over 2 x plus 13. Okay? I'm going to use this to find x. So, 2 over 5 plus 5 over 2. Oh my god, low power mode. Right. 2 over 5 plus 5 over 2. So get 29 over 10x equals 13 minus 7 over 5, 58 over 5. So if I times that by 10 and then divide by 29, I get x equals 4. Now, when x equals 4, y equals minus 5 over 2 lots of 4 plus 13. So y equals times negative 2.5 plus 13, 3. So we're going to get 4, 3 is the point M. And as you can see, am I right in coordinates? Yes, yeah. I am. Perfect. So, now, given that the diagonals of a square, A, B, C, D, meet at M, find the coordinates of the point C. Right, where was A? Right, A is 6 minus 2. Okay, you know what I said about drawing? I'm doing it. A is 6, negative 2, roughly. This is A. M is 4, 3. It's about here. Okay. They never told us, did they, about A, B, C, or D? No, they told us about A. But the diagonals of the square meet at M. Okay, so technically, that's like a square here, isn't it? Okay, perfect. Find the coordinates of the point C. So C is technically opposite M, isn't it? Right? So that means that M is just the midpoint of A and C, surely, right? Surely it's not that easy. So basically, 6 minus 2. We then get to 4, 3. So now our missing coordinate, how do I get from 6 to 4?
Minus 2.
Minus 2, so I'm going to minus 2 again. What do I get? 2. How do I get from minus 2 to 3? Plus what? 5. So 3 plus 5? 8. So the coordinates of C is 2, 8. No way is that easy. Let me just get the mark scheme up. Okay, so that's completely correct. I think the hardest part of that was just, this is why I have to draw, to actually visualise what's happening. Okay? Does this drawing look pretty?
No.
No, I'm not Picasso. I know it. It's okay though. It gets the job done, makes more sense in my head.
Yes, sir, did we get it?
So just to clarify, because this is the midpoint, I'm basically saying from 3, what's happening here? This coordinate is 6 minus 2. This coordinate is 4, 3. So I'm saying I had to go backwards 2 and up 5. Right? So to get to C, I'm going to go backwards 2 again and up 5. Okay, I'm just counting squares. It's that simple. Okay, question 9. So, figure shows part of the curve with the equation y equals a cos. Okay, first of all, we know this is cos, right? So I'm just going to remember cos cuts. Looks something like this. We know it's at 1 and minus 1, 90, 270, 360, 180, right? I should make sure I know where everything is. It then says A is a constant. Brilliant.
And Miss, you already have 30 and negative 3, so you can just notice 3.
Negative 3. Oh, I didn't read this yet. The point P is a minimum point and has a coordinates of 30 and minus 3. Okay, so I've multiplied this by 3. So A is definitely 3, right? Wow. Easy. Okay. Then it says this is also 30. Okay, 30. So our minimum point, now, this is A cos x minus 30. So it means we added 30, right?
Yeah. Because Miss, it does opposite. It's quadratic.
Yeah.
Q is at 900.
But wait there. I don't think this is just 3. This is negative 3.
No, Miss.
Yes.
It's a minimum. It's a minimum point. It says it's a minimum point.
I get that it's a minimum, but look. We can't. If I move this by 30, add 30 here, right? Look. My new axis is going to be here. This point has now come to here. So A is negative 3, okay? Yeah, it caught you, it caught me. We all got excited. Right, A is negative 3. The point Q is a maximum point. So remember, we flipped it round now, right? So, if you want, we can continue it. If you think, this is... Okay, so from here to here is 360, right?
Yeah.
But, so this is from here to here, from here to here. Right, so look at this. So this is 360, right? 360, 180. But we've got to add 30 because we shifted it by 30. So 360 plus 360 plus 180 plus 30. Okay? What do we get? 720, 800, 930 degrees. So this is 3 and 930 degrees. If Okay, so I know with some of us still confused with this minus 3. Right, let's just stop and take a moment. If I was to draw the cos graph plus 30, if I was to draw this graph, y equals 3 cos x minus 30, right? That's what we want to draw. If I was to draw this, I think about how the cos graph looks. The cos graph looks like this. Yeah? Now, if I multiply it by 3 here, this becomes 3, this becomes minus 3. And then I take away 30, technically add 30, I just move it up a little bit, right? Do you see? So technically, if it's positive 3, the graph is going to look like this. Can you see? This is if it's positive. This is why this has to be a negative, because it's flipped. Flipped over. All right? Yeah? Happy?
Yeah.
Great work, guys.
So, Miss, the answer for part B would be 933.
Oh my God, yeah. I can't believe I've just written that the wrong way round. Right, 9:30 and 3. Yeah, absolutely. Okay, well done.
So, question 10. The curve C has the equation y equals 1 over x squared minus 9. Sketch the graph of C. So, if I'm going to sketch this graph, let's sort some stuff out, okay? Show the coordinates of any points of intersection and clearly stating the equations of the asymptote. So, first of all, what do we know? We know that 1 over x squared looks like this, okay? And we have the asymptote. So, let's have a look at 1 over x squared minus 9. This is going to be moved down 9. So, our asymptote is now going to be at the line y equals minus 9. That means that it's going to cross somewhere on the x-axis. So to find that, that's when y equals 0. So 0 equals 1 over x squared minus 9. 9 equals 1 over x squared. So that means x squared equals 1 over 9. So x equals plus or minus a third. So that's the square root. So now, let's do this properly. If I sketch this nicely. Oh, that is not y. This is x. This is y. So we know it's going to cross here. Oh, here we're going to have an asymptote. So where is our asymptote? This is the line y equals negative 9. This coordinate is a third 0. This coordinate is minus a third 0. And I think nailed it. Perfect. Yeah, this is brilliant. Oh, and obviously, yeah, we have this kind of asymptote here, don't we? That's when x equals 0. Now, I'm not sure if you need to write that. Let me just check. Yes, you do. So make sure you get all of that for all 4 points. Brilliant. And it says the curve D has the equation y equals kx squared, where k is a constant. Given that C meets D at 4 distinct points. Okay, so if we think about that, if we only have y equals kx squared, we only have the option, it's either going to look like this, or it's going to look like this, okay? But it's never going to have 4 distinct points if it's positive. So we know that straight away we're going to have a negative, well, k is going to have to be negative. We're going to need a negative quadratic, right? So that means that k is less than 0. That's like our first little clue. Okay, so we know that we're looking for something like this. Now we have to know, so it's got to be less than 0 and what? Because obviously, if we were, for example, we need to find what else, because we could also be here, and this would have no solutions. However, the bigger we go here, can you see? So it's going to have to be between 0 and something to guarantee that we have our 4 solutions. So let's have a look then. What do we know? We could have a pair of simultaneous equations. So kx squared equals 1 over x squared minus 9. Multiply everything through by x squared. Kx4 equals 1 minus 9 x squared. Move everything to the left-hand side. This equals 0. Okay, now remember we're just trying to find our solutions of k. So where is this? This is where b squared minus 4ac. So we can use the discriminant on this. So I have 9 squared minus 4 lots of k, lots of negative 1. So we'll have 81 plus 4k equals 0. So 4k equals negative 81. K equals negative 81 over 4. Perfect. So the range of possible values, therefore, k has to be less than 0, but greater than minus 81 divided by 4. Perfect. All done. Okay, that is the paper absolutely completely finished. Well done.